Okay, Alex Chrisman here, and today we're going to be doing vector addition. Well, if you're here, you obviously do not know how to do this, so today I will be explaining, along with Ravant Budikonda and Connor Crable, how to do this. So we got three vectors here. We got one at 30 degrees, 17 meters, 138 degrees at a magnitude of 33 meters, and 158 degrees below the horizontal at 12 meters. The way to go at this is trigonometry. If you forgot trigonometry like I did, well, you need to learn it. That's your best friend here. You got cosine, sine. You don't really use tangent all that often, but cosine, sine are your main friends. The idea is that you take this 30 degrees, 17 meters, and split it down into x and y components. So for this number 1 here, you take cosine of 30 times 17, which will get you your y component of 8.5. meters in the x direction. And then for the x, same concept, except with sine, and you get 14.7. For number 2, you got 138 degrees. You just plug it back in and use these different numbers, and you get negative 24.5 for the x, this way, and 22.1 for y. Lastly, you have 158 degrees below the horizontal. Now for this, I split it up into something, usually you don't use it below the horizontal. You convert it over to above the horizontal, which is 202 degrees. It would look like this, however the 202 degrees is right here. And for that, same concept, sine, cosine, you get negative 11.1.
How do you know whether the components are negative or positive?
Well, the way you know it is pictures are your best friend. For me, I define my up direction as positive and my right as positive. So for this is going upwards to the top right, so each direction is positive. For number 2, it is going, 138 degrees, it is going up to the left. So the x direction is going to the left, which is also known as negative in this problem, and it's going up, which in the y is known as positive. For 3, you got it going down and to the left, so both of them is negative. Also, the other way is the numbers also come out negative or positive, so usually you don't have to think about it too much, but you just got to make sure that you define your directions. From there, you add your variables together, and you get negative 20.9 degrees for the x direction, and 26.2 degrees upwards, positive. So you put this into another picture, like pictures are your best friend, and you get negative 51.4 degrees if you're to find the tangent, and yeah.
Wait, so how did you figure out the magnitudes?
These magnitudes?
Yeah.
Well, you use sine, cosine, and tangent, and move over here. If you don't know, sine is equal to opposite over hypotenuse. So if you're trying to, like for this one, you're given what is this called?
Hypotenuse?
Yeah, you're given the hypotenuse, and you're trying to solve for the opposite, which is right over here, opposite of the angle. So opposite would be equal to sine of the angle, let's call it theta, times the hypotenuse. Pretty simple, you just multiply hypotenuse over here, multiply hypotenuse over here, and you get that. Same with cosine. If you're trying to find the adjacent, also known as this guy right here, you get cosine of theta times hypotenuse is equal to adjacent. So for this, you just plug sine of theta, 30, times the hypotenuse, 17, and then you get the x component. No, that's the y component, never mind. Cosine, same thing, you get the x. Any others?
I think that's it.
Okay, well that was vector additions here at AP Physics. Good luck on your AP exam and have fun.
Con los terroristas.
Harlem Shake.